In our video today, we're going to be covering graphs with intercepts and how we go about calculating those. So we want to start with our core definitions of each of these things before we actually dive into calculating them and looking at them on graphs and all of that good fun stuff. So our x-intercept is defined as the point where the graph crosses the x-axis, and it's always going to be written in the form like we have right here. We have some number, comma, 0. The y value for the x-intercept is always going to be 0 because it's crossing the x-axis, so it's not moved vertically at all. Similar to that, we have the y-intercept, and that is the point where the graph crosses the y-axis. The y-intercept is always going to be of the form 0, comma, some number. So 0 is going to be showing up because we're not moving left or right on the x-axis at all, and we're just moving vertically along the y-axis. So I would highly recommend, if you are taking notes on any of this, that you have this written down for yourself as corresponding with the correct x or y intercept in there. So with all of the linear equations that we are going to be graphing, every single one of them will have both an x and a y intercept. The exceptions to this are if we are working with horizontal lines and vertical lines. And we can see and think on that fairly easy. A horizontal line is never going to move down to always have, I should say, an x and a y intercept. Similarly, with a vertical line, it is never always going to be aligned so it will have both an x and a y intercept. It can in some instances, and basically one very rare one, but it is not common with those. So as long as you don't have a horizontal line or a vertical line, you know and you are guaranteed that you can find both an x and a y intercept. So we're going to go through some of the ways that we can actually determine what those intercepts are. We have two strategies that we are going to go through. Our first one is graphically, and our second one that we're going to mainly be using is algebraically. So graphically, we would be given a graph and then have this thing depicted on there for us. All we would need to do is by inspection, meaning we just look at the graph and see where does this thing cross the x-axis, where does this thing cross the y-axis. We write those points down or enter them into an online program that we're using, and then we have our final answer there. So there's not a whole lot that we can do beyond that in terms of determining these things from a graph. It's pretty straightforward. Algebraically, if we are going to solve these things, we need to basically go through and set some stuff up for ourselves, and then we're actually going to do some math. So to do this, we need to first determine which intercept we are solving for. You cannot solve for both the x-intercept and the y-intercept at the same time. They must be done individually and separately. Once we determine that, let's say we're solving for our x-axis here as we're walking through this, I'm going to therefore plug in 0 for the necessary variable. The reason we plug in 0 is because notice the pattern between our two intercepts. One of them has a y value of 0, one of them has an x value of 0. And again, that is always going to be the case for that corresponding intercept that you are solving for. And this is why we make it clear to ourselves, I'm solving for the x-intercept, or I'm solving for the y-intercept as we're going through these problems. So we've plugged in 0 into the equation, and we're going to solve the rest of it down for the remaining variable. If I plug in 0 for y, I'm solving for x, and that gives me the x-intercept. If I plug in 0 for x, then that means I need to solve for y, and that's going to give me the y-intercept. We always write our answers for intercepts as an ordered pair. As a note to anyone who is watching this and you are in my class, I will be docking points if you do not write your answer to an x or y intercept as an ordered pair. If you just say the y-intercept is 7 and the x-intercept is 2, I will not be giving you full points because it is asking for an entire point, and we need to list our answer as such. So we're going to take a look at these four examples here. We're going to use the first one. We're going to take a look at that graphically, and then for the other three, we'll go through and solve those algebraically to get to our answers. So let's jump on over and do that now. Starting with our first example, we are working with y equals 5x minus 35. Now we are asked to find the x and y intercepts of this equation, and we've been given some graph like this. So in problems like these, sometimes you're given the information in the graph up front, and then we just find where those things are from here, and this is our example of that. So I'm looking for the x and y intercepts. I want to see where does this graph cross the x-axis and where does it cross the y-axis. Doesn't matter which one you solve for first. You can go left to right, you can go top down. It's 100% your choice in that. So I'm just going to go ahead and go left to right here and solve for and find my y-intercept first. So remember, the y-intercept always has an x value of 0, so it's going to start at the origin, and it's just going to go straight down until I get to the point here. And this looks like it's intercepting at the point 0, negative 35. And sure enough, that's exactly our y-intercept. If we're going over here looking at the x-intercept where it crosses the x-axis, just counting over 1, 2, 3, 4, 5, 6, 7, so our x-intercept should be at the point 7, 0. And sure enough, it is right there. So on our homework or on the test or anything like that, you'd be writing down x-intercept 7, 0, y-intercept 0, negative 35 for your final answers. And this is all that we really need to do for finding the intercepts if we've been given a graph. Not a lot of work can be shown, and that's perfectly acceptable if that's the case. For examples 2 through 4, we are going to go through and find the x and y intercepts algebraically. So with this one, we're starting with x plus y equals 6. Kind of a weird form to have a linear equation written in, but doesn't mean we can't solve for the x and y intercepts all the same. So we need to, again, determine which one of those intercepts am I solving for first. Remember, we cannot solve for both at the exact same time. They have to be done separately. So I'm going to note here that I'm just going to start off with solving for the x-intercept. I think it's also very handy to write the general equation or the kind of framework, as it were, for what our final answer is going to look like. So the x-intercept is always going to be of the form some number, comma 0. So my y-intercept, my y value I should say, is always going to be 0 for the x-intercept. Now I can plug this 0 in for y in the equation, and then I can solve this out the rest of the way. And I get that x is equal to 6. So my x-intercept based on that is at the point 6, comma 0. Perfect. We have our final answer. It's written as an ordered pair. We're good to go. Let's take a look at the y-intercept. We're going to solve it very, very, very similar way. We know the x value of the y-intercept is 0. We don't know what the y value is, so we're just going to leave that blank for now. And like we did with the x-intercept, we're going to plug 0 in for x because it's in the input spot and the x value spot. So we just plug that in and we're going to solve for y. And after that, we are getting that the y-intercept is going to be at the point 0, 6. So we have our two answers here. And all we're going to be doing with all of the future examples is just determining, all right, I'm plugging 0 in for x or y, depending on which thing I'm solving for, and continuing on and calculating from there. Our third example is giving us the equation x equals 3y plus 9. And we're going to go about solving this the exact same way as we did our previous ones. We're going to set up, or our previous one I should say, we're going to set up the x-intercept, and we're going to set up the, we'll go over here, call it the y-intercept spot. With the x-intercept, we know that the y value is always 0. For the y-intercept, we know the x value is always 0. So So we have our two shells of our answers set up right here for ourselves. And all we're doing is plugging in 0 in for x or for y, depending on which thing I'm solving for, and working that out to get the corresponding x or y value for that point. So we'll write those out and we'll go through those here now. So for the equation x equals 3y plus 9, our x-intercept is going to be at the point 9, 0, and our y-intercept is going to be at the point 0, negative 3. Looking at our fourth and final example of determining x and y intercepts, we're given 3x minus 2y equals 24. So like we did with our previous two problems, we're going to write out for ourselves, here's the x-intercept section of what we're going to be doing. Remember, the x-intercept has a y value of 0. I should be solving for an x value. Then we'll give us a little bit of space here. And we'll go ahead and write in stuff for the y-intercept. Remember, the y-intercept has an x value of 0, and we should be solving for a y value, so I'm going to leave that blank over here. And like we did with our previous problems, we're plugging 0 in for x or y, depending on which intercept we are solving for, and solving for the thing that's left over. Now, just because this one is written, again, kind of weirdly, a little bit differently or anything like that, doesn't mean we're going to change anything in our process. I still recommend we take one step to write out the 0 being plugged in, and then we go through and solve it from there. And therefore, for our fourth and final example for this one, we have an x-intercept of 8, 0, and we have a y-intercept of 0, negative 12. Our second part of this particular section of material has us working with graphing with those intercepts. So this is expanding on what we covered in the 4.1, 4.2 video, where we still need to determine 2 points to graph these things. However, now we can, instead of using 2 random points, while that is still an option, we can use the x and y intercepts if we so choose to do so. So we just went through how to solve for and find the x and y intercepts with 4 examples. We could then set up our set of axes and scale them and label them correctly, and then plot these 2 points for each of these graphs, and then connect everything together, and there we have our final graphed overall equation. Now, it should be noted here that as we are going through some of these problems, specifically numbers 3 and 4, if you would like to, it is advised that you find a third or a fourth point if 2 intercepts are not easily graphable, meaning maybe we get some really gross decimals or fractions showing up in there. Maybe we get a number of 1.39264 for our x value for our x-intercept. That could be a bit tricky to actually graph just at face value. We could probably do a pretty good job of estimating that, but you are welcome and you are advised to determine and find another point that maybe isn't an x or a y intercept to graph that thing if you need to. We'll see that with 1 or 2 of these examples here, but for the most part, we're going to go and just try and make a very reasonable guess and reasonable attempt at graphing these things, even if the numbers are a little off. Let's dive in and take a look at these 4 examples of using the x and y intercepts, and maybe an extra point or 2, to graph these equations. Our first example with graphing with intercepts is the equation y equals 2x plus 6. I do have a graph pre-made and ready to go over here. let's go ahead and start calculating what these x and y intercepts are going to look like. So we're going to go through the same setup that we did with our previous examples. We're going to use the exact same process. Nothing really is going to change in that regard, at least to begin with. So we got our x-intercept spot there. We got our y-intercept spot right here. Perfect. So let's go through and let's calculate each of these x and y intercepts first. Fantastic. So now we have our 2 points, -3, 0, and 0, 6. So I can go ahead and plot those on the graph that's been given to me. Now I did already go through and get this set up for myself ahead of time. Actually, let's see if we can get this locked in on a specific part here so it's not, there we go, it was slightly off the numbers there, so now we're good to go. Let's go ahead and graph this thing. So I want to plot the point -3, 0. So that's going to be, let's see, from the origin, -3, 0, it's going to be right here. And then my next point is at 0, 6. I'm scaling the y-axis by 2s, x-axis by 1, so I go up 2, 4, 6. So I'm going to be right here. And now, if you have a ruler or a straight edge, see if I can make this work somewhat accurately. We can connect these guys together, and there we have our overall graph. Our second example is giving us the equation y equals 4x. So let's go ahead and set up our x and y intercepts like we did previously. I recommend you make this a habit as you're starting off with a lot of these problems. It seems to make it, I think, a little bit easier as to what we are and aren't solving for, and also helps commit which one has 0 for x, 0 for y to memory. Okay, so now that we have our setup for x and y intercepts, we're going to once again plug in zeros accordingly, solve for each of them, and then we'll start graphing this thing. Okay, so what we're finding and noticing here is that the x-intercept and the y-intercept are both the exact same point, 0, 0. This is actually the origin of our overall graph, and we can go ahead and plot that point right down here, just so that way it's in and ready to go for when we actually graph this thing. But we do have a problem, and that's the fact that, yes, I found the x and the y-intercept, but they're the same point. I need 2 unique points to be able to graph anything. So this is where we now need to fall back to what we did in our 4.1 and 4.2 material and choose a different input value, an x value, and then find its corresponding output value, the y value. So if I have 0, 0 as one of my points, it's your choice on what x value you would like to use. You can use +1, -1, +2, -3. It's kind of your choice. I'm going to elect to use +1 here just because I think that'll be a fairly nice number to use. So I'm just going to write that down over here. So I'm going to have x be 1. Let's plug it in and solve this. And now I do have a second point of 1, 4. So I can go ahead and plot that over here on the graph. That looks like it's going to be, let's see, 1, I'm counting by 2's again vertically, so 2, 4, so it should be showing up right around here. Perfect. Now that I have my 2 unique points plotted on this graph, I can bring out the ruler again and try and connect these things reasonably accurately. Link them together right there. So I had to do a little bit of improvising here, but this is something that shows up fairly regularly with these problems, so if it shows up on the homework and problems that you're doing, we now have a way to get around that. You just pick a different input value, find the corresponding output value, and then write that as an ordered pair before we put that on our graph. Looking at our third example, we are once again going to do a lot of the exact same stuff that we did with our previous problems. We're setting up space for our x-intercept and setting up space for our y-intercept, and then we are going to solve for each of those. We'll see what we get coming out of this and then determine if we need to find another point afterwards. If we've got our setup, let's plug in some zeros and find some missing values. Okay, so if we're looking at this, we're seeing, okay, so we've got our 2 points. The x-intercept is over at 24, 0, and the y-intercept is at 0, -4. So 0, -4, we could probably graph on here fairly easily if we wanted to. 24, 0, we might have to do some really weird kind of funky spacing for our x-axis if we wanted to graph that thing. So let's take this opportunity to go through and let's find another point. Maybe we can find something that isn't going to be as far in the positive direction as if we had this 24, 0 in there. Now, notice here that if we're choosing an x value, the number in front here, this coefficient, is a fraction. If you want to avoid having fraction answers showing up, make sure you pick an x value that is a multiple of the denominator. So in this case, the denominator is 6. So I could pick 6, 12, 18, 24, things like that, and that would give me a whole number answer coming afterwards. So I'm going to go ahead and do that down here. So I'm going to choose an x value of 6. Whoops. Other things are showing up. I don't know what that's about. Let's choose an x value of 6. Let's find out what our corresponding y value is. Alright, so this is looking much more reasonable as something that we can graph. I don't know why the keyboard keeps popping up. So looking at our 3 points that we have, looks like 0, -6 isn't going to, or 0, -4 I should say, isn't too bad. And then 6, -3 isn't too bad to graph either. 24, 0, you could do some fancy scaling if you wanted to with the x and y axis to make that work. I don't really want to. I feel like something between, I don't know, -6 and +6 for either of these works great. I'm going to go ahead and fill in the last of my labeling on the graph over here. Oops, make that a better 6. There we go. And then from here, we can just go ahead and plot those points. We have 0, -4. Plot that. That's going to be right down. Oops. Do it in blue here. Have it stand out a bit. There we go. 0, -4. And then our other point of 6, -3. So I'm coming over here to 6, and I'm going down 3, so it's going to end up right there. We'll bust out the ruler and get the last of this thing graphed and put together. Should be noted that as you are making the line with this, if your line isn't perfect, that's not the end of the world. Make sure the points are, though. If you have that, that's going to be more important than making sure the line is perfectly straight. Looking at our fourth and final video for this section, we have the equation 5x minus 2y equals 11. So, opportunity to take a guess. What do you think we're doing? Well, we're doing the exact same thing. We are setting up for the x-intercept and the y-intercept. We're going to solve for each of them and then see what we get from there. So, got that there. Here's our spot for our x-intercept. For y, let's plug in zeros and find out what our 2 points are. Oh, right. So we have our 2 points here. We have 2.20 and 0, negative 5.5. Now at this point in time, we do have the choice if we wanted to do what we did in example 3, which is I'm going to pick some different input values, some different x's to plug into this thing and solve for y. We can do that, and there's nothing wrong with it. I will let you know now that this particular problem is one that it's very hard to find actual really nice input values that are going to produce whole number answers. Even if you were to go and rewrite this thing into a different form, it's still going to be a little bit of a pain. So I want to showcase the fact that even though we are working with some not so great decimals, specifically this one, we can still give a reasonable approximation of that on our graph and get a final answer with this. So let's plug our y-intercept first. So 0, negative 5.5, so it's going to be somewhere right around here. So let's go ahead and plot that. Something right there. For our x-intercept, we have 2.2. Everything is scaling by ones, so we'll go 2.2, something about there. We have to kind of eyeball it when we have decimals that aren't halves, I think, showing up. And there's nothing wrong with that, but again, make sure that you have the points clearly labeled and as accurate as you possibly can. So even with those gross ones, we still have our 2 points plotted, connected together, and our overall graph. As a quick recap of everything that we covered today, we went through graphs with intercepts. We had our definition of the x and y intercept listed here. I would highly recommend that you write this down for yourself, these kind of frameworks of each of these intercepts as necessary. Remember that all linear equations, except for horizontal and vertical lines, will always have both an x-intercept and a y-intercept, regardless of if the numbers are nice or gross or any of that. We then went through how to determine the intercepts given a graph and how to do it by inspection, and how to solve that algebraically. We got a lot of practice with this. Plugging in 0 for x or plugging 0 in for y, depending on the thing that we're solving for, and then solve for what's missing from there. Our last bit was once we had those intercepts, we can use those for graphing, since we just need 2 points, and those could be 2 viable points that we use. We had 4 examples that worked with that. A couple of these had some grosser x and y intercepts, but we saw that we can still work with those. And we had others where we needed to pick a third or a fourth point because the other intercept either really wasn't a nice number or we had a repeat showing up. Both the x and the y-intercept are going through the exact same point, the origin. So now let's go ahead and scroll down, and if you would like to, I'd recommend pausing the video here. Try some of these problems for yourself, see if you can determine the x and the y-intercept for the problems that are listed here. We'll scroll down, and here are the answers. So hopefully you got something similar to these, or hopefully the exact same thing. And if not, I'd recommend going back and just giving your work another look over and see maybe you put a 0 in a wrong spot. It happens fairly frequently. It's totally understandable. Make a slight adjustment to it, and then I think you'll be good to go. But that's everything for graphing with intercepts.